Hello, all of you. Now, the topic we are going to discuss is Op-Amp characteristics or features or parameters of Op-Amp, both ideally and practically. That is how these parameters should be ideally and how actually they are practically seen or observed. So, let's start. The first characteristic is infinite input impedance. That is, total circuit's resistance is infinite at the input of op-amp. Again, second is output impedance. It should be 0. Third is voltage gain. It should be infinite. That is, gain means simply a ratio of output upon input. Fourth is offset voltage, which should be 0. Fifth is bandwidth, which should be infinite. Sixth is Cmrr, that is common mode rejection ratio, which should be infinite. Next is slew rate, which should be infinite. And last is PSRR. Let's now see all these parameters one by one. First is infinite input impedance and is shown by Z in. Z for impedance, in for input. Infinite input impedance or input impedance should be infinite. It is defined as the ratio of input voltage by input current. This should be infinite for an ideal op-amp. That is, there is no current flow in the input circuit. However, this is not possible practically. There is certain current flowing in the input circuit of the magnitude of few picoamperes to few milliamperes too. Next is zero output impedance, that is Z out or ZO. It is the ratio of output voltage to input current. See the differences in both definitions. Input impedance means ratio of input voltage by input current, and output impedance means ratio of output voltage to input current. For an ideal op-amp, output impedance should be 0, but practically it is 10 to 20 kilo ohms. Infinite voltage gain. The amplifier doesn't have an infinite voltage gain, but it has a very large one. Then zero offset voltage. When both inverting and non-inverting inputs are same or grounded, then output voltage from amplifier should be 0. But this doesn't happen practically. They usually exhibit some offset voltage due to device imbalances and other issues. Again, infinite bandwidth. An ideal op-amp has infinite bandwidth. Bandwidth is nothing but the range of frequencies over which the amplifier performance is satisfactory. Hence, it has ability to amplify all signals from DC to highest frequency within the range. But practically bandwidth is finite and dependent on gain bandwidth product, that is frequency at which gain of the amplifier becomes unity. Next feature is infinite Cmrr, that is infinite common mode rejection ratio. Cmrr refers to the situation when same voltage is applied to both the inverting and non-inverting terminal of op-amp. The common mode rejection refers to the ability of op-amp to reject the common mode signal. It is nothing but the ratio of differential gain and common mode gain. An ideal op-amp has infinite Cmrr, which ensures zero common mode gain. Due to this common mode, noise output voltage is 0 for an ideal op-amp. Here, mathematical expression is given as CMRR is equal to mod of AD divided by ACM, where AD is the differential gain of op-amp and it is infinity for an ideal op-amp. ACM means common mode gain of op-amp. As CMRR for an ideal op-amp is infinity, it is able to reject all common mode signals. It rejects any signal which is common to both. However, real or practical op-amps have finite CMRR and does not reject all common mode signals. Next characteristic is infinite slew rate. The slew rate is defined as maximum rate of change of output voltage with time, and it is expressed in volt per microsecond. Mathematically, it is given as S is equal to dV0 by dt at maximum in volts per microsecond. This is important parameter of op-amp. When the input voltage applied is step type, which changes instantaneously, then the output also must change rapidly as input changes. If output doesn't change with the same rate as input, then there occurs distortion in the output, which is not desirable. Infinite slew rate indicates that output changes simultaneously with change in input voltage. Okay, next is PSRR, that is power supply rejection ratio. It is defined as absolute value of ratio of change in supply voltages to the resulting change in input offset voltage. Both supply voltages varied symmetrically. PSRR is expressed in decibels. The formula is shown here below. Delta VOS divided by delta V supply. Again, this table gives characteristics, symbol and ideal value of op-amp. So, first is open loop voltage gain. Symbol is AOL, A for gain and OL for open loop and is infinity in value. Input impedance Zin, it is also infinity. Output impedance ZO, it is 0. Offset voltage VOS, it is 0. Bandwidth infinity. CMRR rho, which is infinity. Slew rate SR should be infinity and PSRR should be 0. So this is all about the characteristics of an ideal and practical op-amp. Thank you.